All right, today we are going to be talking about how do we get special solutions when solving systems of linear equations. So up to this point, we have been solving linear equations, and we have been going through the process of either the graphing method, the substitution method, or the elimination method. Today we're going to talk about the other two possible solutions. So when solving a system of linear equations, there are actually three different types of solutions. The first one is the one that we've been doing, which is one solution. Now, the way that we get that one solution, the answer is simply an ordered pair. And remember, ordered pairs are of the form x comma y. Now, that ordered pair is the point that makes both equations true. On a graph, it's where the lines intersect each other. Okay, now that is what we have been working with. Now what we're going to do is we're going to talk about the two new ones, or the two special ones that occur. The first one is a no solution answer. And this means that there are no ordered pairs that would make both equations true. On a graph, the lines would be parallel to each other. Okay, now in order to not cross, we know those lines have to be parallel, meaning they would never intersect each other. Okay, so if my lines are parallel, it is going to be a no solution answer, because the solution is, where do my lines intersect? And since they're parallel, they would never intersect. So that is why it's a no solution answer. The other special solution is infinitely many solutions. Now, this means that any ordered pair that satisfies one equation would make both equations true. On a graph, the lines are the same. So what does that mean? Well, that means that my slope and my y-intercept have to be identical. Whereas the no solution, I would have the same slope but different y-intercepts. Okay, so the two new ones that we have is we have no solution, meaning my lines are parallel, they would never intersect, and there's no ordered pair that makes them true. Or I have infinitely many solutions, which means that any ordered pair that satisfies one equation would automatically satisfy the other. And on the graph, the lines are the same line. Now, that does not mean that we don't still have our one solution answers. We just graph them, or we solve them the way that we have been. It's just these are special ones that show up. Now, what I would like to do is I would like to take a second and just kind of go through what do these look like compared to what we have been doing. So on this first one, I'm going to go ahead and graph it. The slope would be 1/2. The y-intercept would be -3. So if I come over to my graph, I start at -3 on the y. I go up 1, right 2, up 1, right 2. I connect that line, and there's the first line. The second line, if you'll notice, it is not in y equals format. So the first thing I need to do is I need to minus my x from both sides. Then I need to divide by -2. And that gives me y equals 1/2 x plus 4. So my slope is 1/2. My y-intercept is 4. So 1, 2, 3, 4. From there, I go 1, 1, 2, 1 up, 1, 2, connect them. And what do we notice? Well, those two lines are parallel. So if I said, what's your solution? This would be a no solution answer, meaning they never are going to cross. There is no ordered pair that satisfies both of those equations at the same time. Make sure that when you get this situation that you write no solution, because that is your answer. Okay, let's try another one here. So let's start off with the first equation. So on this first equation, my slope is 2. My y-intercept is -4. So 1, 2, 3, 4 down. From there, I move up to right 1, up to right 1. I connect them. And there is my first line. To do my second line, I need to solve it for y first. So I'm going to minus my 4x from both sides. And that gives me negative 2y equals negative 4x plus 8. Divide by negative 2. And that gives me y equals 2x minus 4. My slope is 2. My y-intercept is negative 4. So if you notice, I come in here, I put my dots, go up to right 1, up to right 1. You should notice that that is the exact same line. So when we're asked what is that solution would be infinitely many solutions, because if I satisfy the first equation, I automatically satisfy the second. Okay? So let's take a look. What does this look like with substitution? So in substitution, I'm going to take this, I'm going to plug it in for my y. So x minus 2 times the quantity 1/2 x minus 3, and that equals negative 8. So at this, I'm going to distribute. So I get x, and that's going to give me minus x. That's going to give me plus 6, and that equals negative 8. Here I combine my like terms, which those cancel out, and I'm left with 6 equals negative 8. So how often does 6 equal negative 8? And the answer would be never. So this is showing me that it is a no solution answer. In order to get a no solution answer using substitution, the variables cancel. Okay, so the variables have to cancel out, and you have to have a false answer. And that signals to us that we are going to have a no solution answer. Okay, what does it look like as well? Let's try it. So we're going to take the 2x minus 4. I'm going to plug that in for y. So I have 4x minus 2 times 2x minus 4, and that equals 8. I'm going to take the negative 2. I'm going to distribute it. So 4x minus 4x plus 8 equals 8. I'm going to combine my like terms. 4x minus 4x cancels, and I'm left with 8 equals 8. So this tells me that I have infinitely many solutions. Now, what signals that? Well, when we look at this, what signals that is, once again, the variables cancel, and you are left now with a true statement. Okay, so the variables cancel and you're left with a true statement on this. And that signals to you that you're doing infinitely many. All right, now, how does this all work with elimination? So what we're going to do is we're going to look here. I need to multiply the top equation by a negative 2. So that would give me negative 6x plus 8y equals 10, and I get 6x minus 8y, and that equals negative 5. Now I'm simply going to add negative 6x plus 6x. Those disappear. Those cancel each other out. 8 plus a negative 8. Those cancel each other out, so I'm left with 0. 10 plus negative 5, that's 5. So what that signals to me, this is a no solution answer. So once again, what signals that? Well, variables cancel each other out, and you are left with a false statement. Okay, let's try this last one with elimination. So this time we're going to have to multiply both equations by something. So on this first one, let's multiply by negative 3. On the second one, let's multiply by 2. So if I multiply by negative 3, I get negative 6x minus 12y equals negative 18. Multiply the second one by 2, I get 6x plus 12y equals a positive 18. Now I'm going to add, so negative 6x and 6x cancel each other. Negative 12 and 12 cancel each other. Negative 18 plus 18 equals 0 as well. So this is going to give me infinitely many solutions. Now, once again, what signals that? It is variables cancel. and you are left with a true statement. Okay? And that is how we do the special cases.